Now we'll see a concept called average memory access time. Okay, so what is average memory access time is, this is your, let's say, memory organization. You have one cache and one main memory. Whenever you access a memory, then first we'll go to cache, and if you get it, that's it. Otherwise we'll come to main memory and we take the block and we transfer it to cache. Then later again we access it, right? So that is, entire thing is called memory access time. So it's a highly variable. It depends on, hit of cache and miss of cache, everything, right? So that's why we say that that is average memory access time. The formula for average memory access time we are going to compute. Finally, how much time on average memory access takes. Okay, we'll see. Before that, we will use some terminology. Since we have a cache, sometimes data will be available, sometimes not. If data is available, then we say, to say that how many times data is available, we use a word called hit rate. What is hit rate is the number of hits. That means how many times data is available in total number of your attempts. Example, let's say 100 times you attempted, out of them 90 times data was available, let's say, then we say that hit rate is 90 by 100, also known as hit ratio. Similarly, miss rate. Miss rate is nothing but number of cache misses by total number of attempts. Let us use M for it and H for hit ratio or hit rate. Now, cache hit time is nothing but, let's say C, that is nothing but whenever data is available in the cache. That means whenever cache hits, then we take the data, right? For that, it takes some time. We know that, right? We have to check the tag bits, everything depends on the, memory mapping technique. So somehow finally you get the data back to processor, right? That time is nothing but cache hit time. That means cache access time. So this cache access time is, let's say, C. Finally, we have three parameters H, M, C. Now miss penalty. What is miss penalty is when you have cache and main memory. Here my assumption is always, data is available in main memory, because this is only two-way model. You have one cache and one main memory. I am assuming that always data is available in main memory. Now what is miss penalty is whenever there is a cache miss, sometimes it happens, then we will come to main memory and we transfer the block to cache, right? So miss penalty is nothing but the time taken to transfer one block from main memory to cache. Okay, let us use miss penalty. After that, what we do, once you transfer it, then we will take the data again back from the cache. That means again we start from the scratch, correct? Now what I want to say is, if you want to calculate average memory access time, this is the formula. What is that is, how much time it is taking for a hit, time for a hit plus miss rate into miss penalty. Why this formula is correct, we will see. We'll try to understand. See, just in every possibility, imagine that you are accessing the memory. If it is, whether it is there in the cache or not, finally we'll bring it to the cache, isn't it? If data is already in the cache, then we take it. Then how much time it will take? C time, because cache hit time is C. Now if data is not available in the cache, then after some time we transfer the data from main memory to cache, right? It takes some time, ignore that. That is nothing but miss penalty. Then after miss penalty of time, data will be available in the cache again, then we take it. This time how much time it will take? C time, because cache hit time is whenever there is a data in cache, how much time it will take? C. Now can I say one thing? However, one cache hit time is compulsory. That's why time for a hit, let's say C, plus some extra. What is that extra? Miss penalty. When? Always? No, only one, few times. How many times? That depends on miss rate, right? If miss rate is M, in M times we will be doing that. What is that? Miss penalty. We will be having miss penalty only how many times? M times, correct? That's why you see C is compulsory always. Time for a hit is compulsory, plus apart from that, so we will be having miss penalties how many times? Equal to miss rate. Understand? If you use this formula, then you are going to get average memory access time. Okay, now let us try to understand this for one numerical example. Okay, example, let's say it is given like this. Cache access time is let's say 1 nanosecond. They give like this in the exam. They say that miss rate is 5%. Okay, then they say that miss penalty, if you miss in the cache, is let's say 20 nanosecond. Then what is the average memory access time, they say? Then simple. The formula is for average memory access time. Average memory access time is 1 nanosecond is compulsory, because however we will be definitely accessing the cache, plus 5% of the time we will be having more. What is that? Miss penalty. How much? 20 nanosecond. That's what. So 5% is 5 by 100 is nothing but miss rate. So I can say that 1 nanosecond plus 5 by 100th of 20 nanosecond. So 25 is a 100. 5 gets cancelled. Then you get 1 nanosecond. 1 plus 1, 2 nanosecond. So finally answer is 2 nanosecond. That means your access time has been doubled. If there is only cache, if always data gets in, you get the data in cache, it's only 1 nanosecond. Because of miss rate of 5%, then you are having extra burden of 20 nanosecond, but only rarely. That's why the effect of that is only 1 nanosecond. That's why 2 nanosecond. In that way, you can answer this kind of questions. Okay. Now, we will see one more model. Okay. So rather than miss penalty, they say something else. We will see that. See this one. You have cache access time C, main memory access time M. This time they are using different terminology, but almost same. Okay. Try to understand. So we access cache sometimes, that let's say C, we access main memory, let's say that is M, hit rate is H and miss rate is small m as usual. But you know one thing, miss rate is nothing but 1 minus H, correct? Example, let's say hit rate is 90%. Then what is formula for miss rate? Total number of misses. If number of hits are 90, then total number of misses will be 10, right? So 10 by 100, correct? So I can say that if hit ratio is 0.9, then miss ratio should be 0.1, because hit rate plus miss rate should be 1, right? This is all possibilities. So hit rate is a fraction. So that's why. So always miss rate is nothing but 1 minus H. Example, 0.9 is hit rate. That means what? I can simply extend it to percentage, right? 0.9 means 90%. That means 90% of the time you are hitting the cache, then 10% of the time you will be missing, that will be automatically 0.1. So that means it's scaled to 1. Finally, all the rates, hit rate plus miss rate should be 1. Okay. So it's a number between 0 to 1, hit rate and miss rate. Then hit rate plus miss rate is 1. If hit rate is H, miss rate should be 1 minus H. So in this model we will see what is the average memory access time. Again, first understand the story, how we get the data. So this is your cache, right? First of all, we'll check in the cache. If data is available in the cache, then we take it. If data is not available in the cache, then we'll come here and we access the main memory, correct? So case 1, case 2. In the case 1, access the cache, right? Assume that case 1 is nothing but hit. Second one is miss. So case 2. So in case number 1, access the cache. In case number 2, what you do is go to the main memory and access the main memory. That takes main memory access time. That means access the main memory. Access the main memory. And while accessing main memory, send all the data to the cache. That means overall, finally you have to access the main memory. Understand? So once you access the main memory and get the data, and when you transfer it, then again fresh, we have to again access the cache, right? So that takes again cache access time. What I want to say is, in case number 1, we have accessing the cache. In the case number 2, we have accessing the main memory and accessing the cache. That's why. So I can apply this formula like this. One method is hit rate. How many times you are doing this one and how many times you are doing this one is important. Example, let me tell you one analogy. Let's say you are the person who you are selling something. Let's say you are doing business 2 days, one Sunday, one Saturday. Sunday you got profit 10 rupees, okay? But Saturday you got profit 5 rupees. Then what is the overall profit? 10 plus 5 by 2. Very simple, right? Simply add them and divide by 2, because 10 is one case, 5 is another case. Total profit is 10 plus 5 by number of cases, right? So in that way. Now what if you have this one? you have done business 3 days, 2 Sundays and 1 Saturday. Okay. So Sunday always your profit is 10 rupees. Okay. Then Saturday your profit is 5 rupees. Then what is your average profit? 10 plus 10 plus 5 by 3, correct? Similarly, can I say one thing? If your Sunday's profit, though you know did 2 times, that means you sold some items 2 times, 2 Sundays. But let me divide it into 2 cases. One Sunday, one Saturday, because the day is same, right? So there are 2 Sundays, right? 2 times Sunday occurred and the profit is 10 rupees. Do we say simply 10 plus 5 by 2 and say average is this one? No, right? Why this is not average? Because there are 2 Sundays, 1 Saturday, then there are 2 10 rupee profits and 1 5 rupee profit. That's why 2 into 10 plus 1 into 5 by number of attempts 3, correct? In the same way we can do it. Okay. So what I am doing is number of hits I am assuming Sundays, number of misses I am assuming Saturdays, and accessing the cache is the penalty on the days, and accessing the main memory plus accessing the cache is penalty on those days. Okay. Now number of hits, let us assume that is h1. Okay. Just for h1 is a new variable. What is that h1? It's not hit rate. Number of hits. Number of hits are h1 in the long run. Then what is the access time of cache? C, right? h1 times you get penalty of C. Assume that, let's say miss rate is m1, sorry, not miss rate, number of misses are m1, then these many times you will be accessing the main memory. What is accessing the main memory time? M, capital M, plus accessing the cache time, C, correct? So I am using 2 new variables. One is h1, which is nothing but number of total hits in the down the line. Okay, that means in the total over period of the time. M1 is nothing but over the period of time, in the long run, the number of misses. Then what is this formula? H1 into C plus M1 into M plus C is nothing but total number of access time. That means total access time over lot of instructions, right? Now what I do is I divide this entire formula by, because I want to find out average, right? Average memory access time. This is total memory access time for how many times? Let's say total number of attempts. These are all total number of attempts. Now you will get clarity about H1. What is H1? Number of hits. What is M1? Number of misses. Then what is H1 by total attempts? We know that is a formula for hit ratio, correct? Capital H. So what is the formula for M1 by total number of attempts? That is a formula for miss ratio, correct? So H1 by total number of attempts can be written as, I am removing this part now, because H1 by total number of attempts, I can divide this formula like this: H1 by total attempts, M1 by total attempts. We know that, right? Total attempts. Simple mathematics. The total attempts was dividing these 2 components. I am separating it. Now H1 by total attempts is nothing but H. That means H into C plus M1 into M1 by total attempts is miss ratio, M into capital M plus C, right? Let us simplify it further. I simplify here. So average memory access time is hit ratio into C plus miss ratio into capital M. I am multiplying it. Miss ratio into C, right? But HC plus MC, if you simplify, what happens we will see, into M capital M. So C common, then it will be H plus M into capital M. So H plus M, hit ratio plus miss ratio is always 1. So C into 1 plus M into capital M. C into 1 is nothing but C, cache access time, plus M into capital M. From now onwards, whenever you have a 2 level memory, one cache and one main memory, so these are the parameters. Cache access time is given, main memory access time is given, hit rate is given, miss rate is given. Then average memory access time is C, cache access time, plus M into capital M. How to understand this formula I will tell you. Always you will be accessing the cache, whatever the case. That's why C plus extra. That extra is capital M, memory access time, only few times. How many times? What is the ratio? M into M. Sorry, M, right? That's why the ratio into M. Understand? This is the formula for average memory access time in this case. Now we'll extend this to one more level. Sometimes that means majority of the modern computers will have two cache systems. I mean two levels of caches. One is called L1 cache, second one L2 cache. The target of L2 cache I will tell you. L1 cache is generally will be very small so that its access time will be very less. Okay, remember it. Why we use two caches we will see. L1 cache, L2 cache. The target of L1 cache is we will keep it very simple and very small so that its access time will be very high. Okay, access time is very less, not high means here less, very less. That is what my intention. So that, but because it's very small, the number of misses might be more. Okay, so hit ratio I can't maintain. Why? Because it's not huge. When it is not huge, what happens? There is a high chance that you get lot of misses. But whenever there is a miss, generally if there is no L2 cache, what happens? Then we have to go to this lazy main memory, right? And this takes lot of time. I want to avoid it. That's why in between these two, I keep another cache called L2 cache. Whenever there is a miss, but still it is not really miss because L2 cache will catch it. Okay, we'll plan this L2 cache little bit large so that its access time is reasonably good. Example, let's say main memory access time is 100 nanosecond. L1 cache access time, because of its very smallness, only 1 nanosecond. Then I will design L2 cache that is also like made of static RAMs, but it is little bit big. So its hit ratio will be huge, but it takes let's say 5 nanoseconds of time. Just some details, right? So in that way, if you plan, what is going to happen? Why we get advantage, I will tell you. If you miss it, example, let's say hit ratio, definitely hit ratio will be affected. So assume that let's say hit ratio is very less, 80%. Okay. But L2's cache, because its size is very high, reasonably good, then its hit ratio is 90%. Okay. Now main memory's hit ratio, let's assume 100%. Now what are we going to do is 80% of the time, so we will be having only 1 nanosecond, correct? But in the 20% of the time we will be coming here. How many times we are going to come to the second cache? 20% of the time. In the 20% of the time, generally the penalty will be 100 nanosecond if there is no L2 cache. If there is no L2 cache, think about it. Then in the remaining 20% we will come here and we get penalty of 100. Of course, plus this one also. That means I can say that if there is, let us calculate, assume first there is no L2 cache. If there is no L2 cache, then average memory access time will compute. Average memory access time is, see, hit ratio very less. Then what is the formula? In L1 cache and main memory model, just remember it, L1 cache plus main memory, that's it. Simple. Always we access L1 cache, it takes 1 nanosecond plus the remaining percentage, 20% of the time we will come to main memory and the penalty is huge, 100 nanosecond. So it would become 1 nanosecond plus 20% of 100 is 100 gets cancelled, 20 nanosecond. So here it is becoming 21 nanosecond, right? 21 nanosecond. What if I keep one more cache in between? Then how much benefit we are going to get, we will see. So first of all, we will search in the L1 cache, understand? Then if you don't get it, then we'll come to L2 cache. If you don't get it here, then we'll come to main memory. Sir, what is the formula for it finally? Very simple. First, come here. If you don't get here, then you come here. If you don't get here, then you come here. And once you get here, then transfer the data to L2 cache and again transfer the data to L1 cache. And now access it. Try to understand. So you have L1, L2, main memory, which is the final one. If you understand this concept, then you can answer any question. That's why it takes a little bit time. Have patience. If you get data in L1, take it. So what if I don't get in L1? Case number 2. You don't get in L1, but you get in L2. Then simply transfer it to L1, like main memory to cache 1. How did you do that? In the same way, transfer it to here and access it. Sir, third case. What if I don't get in L1, then I came to L2, and what if I don't get in L2? then go to main memory. My assumption is always data is there in main memory in the last hierarchy, last level. Okay. Now data is not in L1, data is not in L2, but data is in main memory. Some students might have this doubt. Sir, sometimes we heard that in operating system, so main memory may not contain all the data. At that time there will be another memory called secondary memory or hard disk. From hard disk we get it, right? That case we will see later. Here let me assume that now main memory definitely contains the data. Okay, of course we can extend that to later to remaining things. So in that case, not available in main memory, then simply transfer the data to L2, then again transfer the data to L1. Understand? That means keep the data in L2 and L1 also, then again access L1. Understand? So we have to find out what is the average memory access time in this model, right? So that we can see the difference between this 2-level model and 3-level model. Okay, so remember this one. In the 2-level model where you have only just L1 cache and main memory, the average memory access time was 21 nanosecond. Because of this 3-level, are we going to get any advantage? If you want to know, you should find out the formula for average memory access time in this case. Let us do that. Now we'll see how to develop the formula for L1 cache, L2 cache and main memory. Okay, just observe the process. So case number 1, if data is available in L1 cache, we take it, right? Case number 1 is done. So case number 1 is, I can say L1 hit. Case number 2. So what if L1 doesn't hit? That means if L1 miss occurs. So L1 cache miss occurs, then we will come to L2 cache, correct? In that there are two cases. When L1 misses, then we will go to L2. Then at that time L2 may hit, right? And L2 miss. These are the two cases. Now, is there anything else? Nothing, right? Because always, here we get the data. The only possibilities you get, that means you have two options only for L1 and L2. L1 hits, L1 misses. L2 hits, L2 misses, correct? Then if L1 hits, we don't come here. And L1 misses, then we will come here. In that if L2 hits, then we don't come to main memory. If L2 also misses, then we will go to only one thing, that is main memory, right? So let us understand the penalties one by one. Whenever there is a L1 hit, we will see. In this case number 1, what happens, we'll see. The penalty in this L1 hit is, that means we have to access that cache. So cache access time. Let us assume that L1 cache access time is C1. So C1, right? So penalty or profit, whatever in our analogy, that is profit, right? So the profit is C1. Now we'll come to case number 2. In that is when L1 miss occurs and we will come to L2 hit. Case number 2, in this case L2 hit occurs. So if L1 miss occurs, then we'll come here, and if you get the data here, then according to our hierarchical access, so this method is called hierarchical access, then we will transfer the data first from L2 to L1, then after that we fetch it. Okay, that is a simple technique. For that we have to access L2 cache, isn't it? Transfer from L2 to L1, then for that we have to access L2 cache, then after that get the data from L1 cache. You remember one thing, transferring data from L2 cache to L1 cache is nothing but L2 access time. Okay, so in that L1's access time is also involved. Try to understand. Whenever, that is what general assumption. Okay, whenever you are transferring the data from L2 cache to L1 cache, that is typically is called L2 access time. Okay, so that's why whenever you have data in L2 but not in L1, then transfer the data from L2 to L1. For that, how much time it will take? It will take C2 time. Then later we have to take the data from here. That obviously takes C1 time. Remember it. C2 plus C1. Okay. Now we'll come to this case where L1 miss, L2 miss, and you get the data in main memory. In that case, the penalty you see, first transfer the data from main memory to L2 cache. That is nothing but main memory access time. Okay. So I am using this main memory access time word to say that we are transferring the data from main memory to L2 cache. That entire thing is main memory access time. Then after that we don't stop. We transfer the data from L2 cache to L1 cache. That is L2 access time. Okay. For that whatever the time is involved, then we say that is L2 access time or penalty at L2. This is penalty of main memory. Understand? So finally, I can say that after that what you do? Then again you take the data from L1 cache, because once data is filled in L1 cache, again we have to take it. To take the data from L1 cache, that is L1 access time, correct? So finally what I want to say is, whenever data is available in main memory but not here and here, then the penalty is transfer here to here, that is main memory access time C2, right? Sorry, that is M, okay, capital M, plus transfer from here to here C2. Then after that, transfer from this L1 cache to your CPU register, right, wherever you want, that is C1. So this is the story. Now let us simplify this formula, like what you get we will see. Okay, let me simplify it. The first, how many times, what is the ratio you come here? What is L1 hit ratio? The hit ratio of L1 cache is H1. That means with H1 probability, otherwise H1 times, we will come to C1. The penalty of C1 you get only H1 times. That's for H1 into C1 plus. So this one you are coming here means what is the possibility for that L1 miss and L2 hit? What is the possibility? What is the percentage of time L1 misses? That is L1 miss ratio. What is L1 cache miss ratio? 1 minus H1, right? So 1 minus H1 times on that L2 hits. What is the L2 hit time? L2 hit time is H1, right? Sorry, H2, correct? Try to understand. So 1 minus H1 times L1 will miss and L2 will hit H2 times. That's why 1 minus H1 into H2, this is the possibility of coming here into C2 plus C1. Okay. Plus, now this case. When are you going to come to main memory? For that L1 miss, L2 miss. The number of times L1 misses is 1 minus H1 into number of times L2 misses 1 minus H2. That's why rare combination you see. 1 minus H1 is very rare, into 1 minus H2 if you do, that will be very rare. Only in that many times you will be getting M plus C2 plus C1. Okay. So this is the final formula for average memory access time. Okay. H1 into C1. L1 hit time is H1. L1 hit rate into C1 plus L1 miss rate into L2 miss hit rate into C2 plus C1 plus L1 miss rate into L2 miss rate into M plus C2 plus C1 is the formula. Okay. Now if you simplify it, whatever you get, the same thing you can get it by another technique. Rather than simplifying it, you can simplify if you want. Then I will be simplifying it in another way. Okay, with some reasoning. What is that reasoning you see? This L1 will be definitely accessed, correct? You will be accessing this cache 100%, right? So 100% of the time, that means, so every time you will be accessing this L1 cache. That's why I can say that the access time of L1 cache is C1. C1 is compulsory. Plus, then extra thing what you are getting is sometimes this one, sometimes this one. How? When you are getting only L2 cache. So there is no only L2 cache, because if you hit L2 cache, then we have to access L2 cache, because we are transferring from here to here. At that time L2 should be accessed, right? That is L2 access. Second thing, if you miss here, then we will be transferring from here to here and here to here. At that time again L2 will be accessed, right? So I want to say that in the remaining cases C1 is compulsory every time. That means L1 cache access time is compulsory, but this is only compulsory when L1 misses, right? What is the percentage of time you are missing L1? That is nothing but 1 minus H1, right? That means when you miss the cache number 1, then definitely we will be accessing L2 cache. What is the accessing time of that? C2. Fine. Plus, now we will see main memory access time. When are you going to do this main memory access time? Only when L1 misses, L2 misses. What is the, possibility of L1? What is the percentage of time you miss L1? That is 80% or, sorry, 20%, right? That means 1 minus H1 into, you have to miss this one and this one, right? That is a rare possibility. That's why that rare possibility is nothing but that will occur 1 minus H1 into 1 minus H2 time. Okay, example, let's say 2% of the time you write one exam, let's say 1% of the time you pass. Out of that, only 1% of the time you pass, then overall the passing percentage is 2 into 1 by 100 into 100, correct? That means in the same way here also, L1 cache misses 1 minus H1 times, then L2 cache, on that L2 cache misses 1 minus H2 times, then total number of misses are 1 minus H1 into 1 minus H2. Only in this case we will come to main memory and we access it. So main memory access time is nothing but transferring data from here to here, that takes m time. So that is simple way, right? But whatever the previous way if you have seen, that is, and this one both are same. If you simplify the previous one, you get it, right? So finally, let me summarize. When always you access this L1, C1, okay, I am repeating it. So if you understand, then you can drag it, understand? Now C1, when you hit it, you take here to here. When you miss it here, then there are two cases. Case number one, when you miss here, then definitely one case is you hit here so that you transfer here to here, that is nothing but L2 access time C2. But C2 will occur only when you miss here. What is the percentage of time you miss? 1 minus H1. Now in that 1 minus H1, so C2 will compulsorily occur. Second one, on that 1 minus H2 time, in this 1 minus H1, C2 is compulsory, but 1 minus H2 times you will be accessing main memory, correct? That's why, what is the main memory access time? M. If you simplify it, C1 plus 1 minus H1 into C2 plus 1 minus H1 into 1 minus H2. In this rare case and in this rare case, M will occur, 1 minus H1 into 1 minus H2 M. So this indicates, that means in this rare case, what is the rare case? When the first cache misses, this is the case, this value imperates that, otherwise that this value says that definitely now we missed L1 cache, then at that time we will be transferring definitely data from L2 to L1, that's why C2 is compulsory, understand? So this is the formula. If you don't understand anything, you remember it, okay? So this formula is very important for us. If you remember, then you can answer any gate question related to that multi-level cache access thing, okay? Formula. Average memory access time in this two-level system is C1 plus 1 minus H1 into C2 plus 1 minus H1 into 1 minus H2 into M. Let us solve that numerical problem. C1, what is cache number 1 access time? 1 nanosecond plus remaining 20% of the time we will miss the first cache. At that time we will definitely access L2 cache, that takes 5 nanosecond compulsorily plus. Now in this case, already when you are in this case, there is another case called L2 miss, that will occur 10% of the time. You see, already in 20%, that means we are in rare case. In this rare case only we will be having M. What is that? Main memory access time. If you remember, in the previous example we took main memory access time 100 nanosecond, right? So 10% of the time 100 nanosecond, it would become 1 nanosecond plus 20% of 5, 25 is 100, 100 gets cancelled, otherwise let me write it, 20 by 100 into 5 nanosecond plus 10, see 20 by 100 of 10 by 100 of 100 nanosecond, right? That is the formula. 1 nanosecond plus 25 is 100, 100 gets cancelled, then it will be 5 nanosecond, sorry 1 nanosecond here, plus, so 100, 100 will be cancelled, here 20, 0, 0, 0, 0 will be cancelled, you get 2 nanosecond, right? So 2 plus 1, 3, 3 plus 1, 4 nanosecond, whereas in that example it was 21 nanosecond. If you remember, if there is no L2 cache, only if you have L1 cache and main memory, what happens? So always we have to access L1 cache 1 nanosecond, plus when L1 miss occurs 20% of the time it happens, we will go to main memory and we transfer from main memory to L1 cache, that takes 100 nanosecond. That's why, so it would be 20 plus 1, 21 nanosecond, right? That is very much high if you compare with 4 nanosecond. That's why we introduce one more cache, okay? So what people do is they will try to use L1 cache to reduce the access time. That means they will have very small size of L1 cache so that quickly we can get the data, and we just compromise our hit ratio, but we will keep one more cache so that though you miss in L1, okay, I mean lot of number of times, then still we will come to L2 and we will try to get it. If in L2 cache if you miss, then only we will come to main memory. That means what? We are reducing the possibility of coming to main memory. That is very important point in this multi-level of cache. Okay, this is all about accessing the multi-level cache. Okay.